Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So we need to find the difference in the two speeds before they hit the ground. We have the electric field. This is simply going to be 150 volts per meter. We have the mass of the two masses, so 0.67 kilograms. Again, there are two masses. We have a height drop of 2.00 meters. We'll just rewrite that, 2.00 meters. The first charge has a positive 650 microcoulomb. This would be 6.5 times 10 to the negative fourth coulombs. And then the second charge has a negative 650 microcoulomb. So again, this would be negative 6.5 times 10 to the negative fourth coulombs. Now at this point, we know that the energy initial is going to be equal to the energy final. And we can say that the gravitational potential energy plus the potential energy stored is going to be equal to half of mv squared. Now, at this point, we can solve for v and say that v is going to be equal to 2 times gh plus q e times h over m. Again, v here, capital V, simply equals e times h. And this will be divided by m, and then this entire thing to the 1/2 power. So the velocity of the proton is going to be equal to, we should just get a new workbook. So we can say that the velocity of the proton equals 2, and then 9.8 times 2 plus 6.5 times negative 4. And then this will be 150 times 2 divided by 0.670. So this is going to equal, and then also the 1/2 power. So this is going to equal 6.3073 meters per second. V minus, so essentially the velocity of the electron is going to be equal to 2 and then 9.8, 2 plus 6.5, not velocity of the electron, the velocity of the negatively charged mass times 10 to the negative 4. And this is actually, this right here, because it's negative, it's going to be plus a negative charge. So that's very important to include. Just remember that we're trying to calculate the velocities of a positively charged mass and negatively charged mass. So when we're accounting for charge, make sure that you have your sign correct. This will be, again, 150 times 2, all divided by the same mass, so 0.670, all to the 1/2 power. This is going to equal 6.2143 meters per second. So we have that delta V is simply going to equal 6.3073 minus 6.2143. And we have that the change or the difference in velocities right before they hit the ground is going to be 0.093 meters per second. So this would be the change in velocity right before the difference in velocities right before they hit the ground. That is the end of the solution. Thank you for watching.